So let's see if we can go through a couple of examples here that takes what we saw in the previous video and gives it a little bit more structure so we can start to get a sense as to how this equation translates into an ellipse. So the first thing we need to do is, it might be helpful for us to see the general equation for an ellipse. So x minus h squared over a squared plus y minus k squared over b squared equals 1. So the first thing to take note of is that the a and b are kind of determined by which denominator is bigger. So in the case of this first example that we're going through, we can see that the bigger denominator is underneath the x, so that's going to be our a squared. The smaller denominator under the y is going to be the b squared. So that means that we're working with an ellipse that's going to be stretched in the horizontal direction. So before we even get to the center and the vertices and the foci, I think it's important for us to get the values of a, b, and c, because those help us with the actual plotting of the points on the curve of the ellipse. So if a squared is under the x, since that's bigger, that means a is going to be 5. B squared is underneath the y, so that means b is 3. And then if you'll recall, the relationship between a, b, and c, no matter how the ellipse is oriented, is a squared minus b squared equals c squared. So if we plug in a squared, it's going to be 25 minus b squared is 9 equals c squared, or 16 equals c squared. So if we take the square root of both sides, we get c equals 4. And so now with that, we can start to piece together the shape of the ellipse. We can see hopefully that the center is 0, 0, since we have no number being added or subtracted from the x or the y. So our center is at the origin. So a is, if you look at the previous slide, a is that distance from the center to the vertices, the long way across the ellipse. And so since a is underneath, since that 25 squared is underneath the x squared, that means a is 5. So I'm going to go 5 in the horizontal direction each way. So those are my vertices. And so the coordinates of those points are plus or minus 5, 0, or we could list them off independently, 5, 0, and negative 5, 0. But for shorthand, we can just put plus or minus 5, 0. Foci we'll get to in just a second, because we can use the b value to figure out how far in the vertical direction, in the y direction, our graph is going to extend. So that's going to be 3 units up and down. So those points don't have any special name or anything like that. They're just the endpoints of the minor axis, the short distance across the ellipse. It's the endpoints of the major axis, so in this case the horizontal way through the ellipse, that have the specific name of being vertices. And so really at this point we have enough to be able to draw the sketch of our ellipse. We know how far to the left and right it extends. We know how far up and down it extends. So that's enough for us to be able to draw a sketch of the curve. We do, however, need to make sure that we locate the foci, because if we go back to the definition of an ellipse, we're going to see that it's all based on those foci. Remember, the points that are on the curve of the ellipse are those that if we add the distances from these two foci, they are going to, that distance, the sum of those distances is always the same. And so with c being 4, c is that distance from the center to the foci, and it's going to be in the same direction as the vertices. So those are going to be these two locations here. So there's one, and there's the other focus. And so we can see that the coordinates of those are plus or minus 4, 0. So we've identified all of the relevant features. We've got the center is at the origin. We've got the vertices are 5 units to the left and to the right of the center point. We've got the foci are 4 units to the left and to the right of that center point. So those are determined by A and by C. And then B helps us with that short distance across the ellipse. So that helped us with the plotting of the curve. So that's the first example. Moving on to the second one, we see that we're no longer centered at the origin. We've got numbers that are being added or subtracted to the x, so our center is going to be in a different location. We're still going to have to figure out what a, b, and c are, but this time if we look, the larger denominator is under the y squared instead of being under the x squared, and so that's a. A squared is always the larger of the two denominators. So all this is telling us is that this ellipse is going to be stretched in the vertical direction rather than in the horizontal direction. So if a squared is 64, that means a is 8. B squared is the other denominator, so the square root of 36 is going to be 6. And then once more, we've got this a squared minus b squared equals c squared relationship between those three measurements. So we're going to go with a squared is 64 minus b squared 36 equals c squared. So 64 minus 36 gives us 28. So unfortunately that doesn't turn out to be a perfect square, but we can still take the square root of both sides. And so if we leave that in radical form, just clean it up a little bit, we get c is equal to 2 root 7. So we can put that there. Now, for graphing purposes, we're going to need to know what that number is as a decimal, just so that we can kind of estimate it. So square root of 28 is a little bit bigger than the square root of 25. We know square root of 25 is 5. So it's going to be a little bit bigger than 5, so maybe like 5.3-ish or something like that. But that's only for when we want to graph it. Otherwise, we want to know what that exact number is put in radical form rather than expressing it as a decimal. So now we're ready to start to translate the information that we have here with the a, b, and c values and what we see in the equation for h and k to start finding all the relevant features. So hopefully we can identify the center point. So x minus 3 means the x coordinate of the center is 3. Y plus 2 means the y coordinate of the center is negative 2. So I'm going to go over 3, I'm going to go down 2, and so there's the center of my ellipse. Now A is that long way across the ellipse. So in this case, again, because a squared was underneath the y squared denominator, we're going to go up and down 8 units. So 2, 3, 4, 5, 6, 7, 8 up, and then 8 down takes us all the way down there to the bottom. And so these are our two vertices. Those are the places where the graph, those are the vertices. Those are the farthest points that the graph ever gets, that the ellipse ever gets from the center. So just in the interest of space, I'm going to write it down here. So the coordinates of those 2 points, the one at the top, we can see is at 3, 6. And then for the one that's down at the bottom, that one is at 3, negative 10. So those are the coordinates of the two vertices. We, again, just like we did before, we can figure out how far to the left and right our ellipse extends. So that's where B comes in. So I'm going to go to the right 6 units, and I'm going to go to the left 6 units. So that's as far to the left and right that our graph is going to extend. Those are not vertices, however, as I mentioned before. Those are just the endpoints of the minor axis. So I've got enough to be able to sketch my ellipse. But the key features of the ellipse, the shape doesn't exist without them, are these foci. So we need to make sure that we get those coordinates. Again, just in the interest of space, I'm going to write the result here. Now, we already established that C was 2 root 7, which estimates to be about 5, a little bit bigger than 5. So I have it as 5.3-ish. So to plot the points, I'm going to go up a little bit more than 5 units and down a little bit more than 5 units from the center. So if I put 1 point there, kind of between 5 and 6 units away, 1, 2, 3, 4, 5, a little bit more than 5 units away, there are my two focus points, my two foci. But when I give the answer as to what the exact coordinates are, I don't want to put 5.3-ish. What I'm going to do is I'm going to go off of the center. So I can see that the x-coordinate is the same for both of them. It's going to be 3. And then from my center point, which is -2, I'm either going up 2 root 7 units, so that 5.3-ish, or I'm going down 5.3-ish, that 2 root 7. So the way I'm going to write it is it's going to be 3, the x-coordinate, comma, -2 plus or minus 2 root 7. So that's the way that I can give the exact locations of those foci. So instead of writing it as a decimal where I have to round off and it's not going to be precise, now instead I can give it as an exact answer because I'm traveling 2 root 7 up from the center and I'm traveling 2 root 7 down from the center. So we can write that as that y-coordinate -2 plus or minus 2 root 7 with an x-coordinate of 3. So that's an ellipse that's not centered at the origin. We can see that with the h and k, and we've got this non-integer value for one of our a, b, or c's, in this case c. So that's the way that we would handle that.